We are going to consider the reaction where phosphane is converted to phosphorus and hydrogen. We're given the K value at 25 degrees Celsius and asked what happens to a container of phosphane, phosphorus, and hydrogen at equilibrium if we add more phosphane, we add more phosphorus, or we decrease the volume at a constant temperature. So this problem is also getting at Le Chatelier's principle again. I briefly covered a problem where I evaluated Q and K and then saw which direction the reaction would shift to achieve equilibrium again. And this problem is pretty similar, it's just a bit more qualitative. So we can first go over adding more phosphane. And so I do think it's helpful to write out the formula for Q to help you solve these problems. And Q is a similar formula to K, it's just that it describes our reaction at any given time, not just at equilibrium. So we have that it's equal to the concentration of our products raised to their stoichiometric coefficients over the concentration of our reactants raised to their stoichiometric coefficients. So if we increase the concentration of phosphane, we can see that Q decreases, and so Q will be less than K now. And the system wants to shift back to equilibrium, so in order to increase increase Q to equal K, we're going to need to make more products. And what this means is that the forward reaction becomes spontaneous or favorable. So we will shift to make more products in this scenario. And then we can go over adding more phosphorus. And this is pretty similar. So again, looking at our formula for Q, if we increase the concentration of phosphorus, our Q becomes greater than K. So in order to shift back to equilibrium, what we want to do is increase the concentration of our reactants. And that means that in this case, the backwards reaction becomes spontaneous. And that is what is favored in this situation. So now we can go over what happens if we decrease the volume at a certain temperature. So we know that our concentration is pretty much just a number of moles over a volume. Those are the units of concentration. So we know, looking at Q again, and I'll write this formula again. We know that the concentration of our phosphorus is proportional to N over V. The concentration of hydrogen is proportional to N over V to the 6th. And the concentration of phosphane is proportional to N over V to the 4th. So overall, Q is proportional to some N over V to the 3rd. So this is telling us that if we decrease our volume, we're going to increase Q because our volume is in the denominator. So this is now a similar situation where if we increase Q, Q is now greater than K. And to shift back to being equivalent to K, we need to increase the concentration of our reactants. And again, this means that the backwards reaction is favorable.